Vande Gujarat.
Hello, good morning to all. Today we have met here for conducting a workshop on calculus. Calculus is a very interesting subject and vast subject, but majority of students fail to understand the beauty of this calculus. So today's workshop will focus on entirely calculus, but not in conventional way. We will be doing something which is entirely different than the approaches followed in teaching calculus. So my entire effort will be on how to teach calculus in relation to the real life situations or real life problems. So how calculus is related with real life, that will be my focus area, and how we can leverage the technology to learn and use calculus. That is another objective of me today. With that, I will be starting my workshop, and myself Chanchal Das, and I am a fellow of Institution of Engineers. So, and we are from a startup company. It is not any academic institution. We are from Das Scientific Research Labs Private Limited. Our main focus is on to teach mathematics in a new way. That way we are researching on our startup company and following some geometrical approach in teaching mathematics. So this is something written about myself. I have some invention, 3 inventions I have, and I am a mechanical engineer with an MBA and worked with Hindustan Fertilizer Corporation for 8 years and then ONGC for 21 years. And there are a lot of awards and skills and publication, and many countries I have visited. I am not going to elaborate it much. So today's session we are targeting like this. First session actually we wanted to start at 11, but due to some technical issues it was late. So first session will be the introduction, then second session will be integration, third session will be differential equation, and fourth session final is series. So how it is related to life, I will be discussing mostly on that. So one of the quote is that mathematics is for solving real life problems and not for puzzling people. So many of the people when or we set question papers, we give some puzzles to solve the students, but I feel mathematics and puzzle is two different aspect, and we should differentiate that when we teaching mathematics. And here our main objective is to explain a new approach of teaching mathematical concept. What is that new approach, I will discuss while I go ahead. And my present action, what I am trying to do, this is actually when we think of mathematics, no, we think of a lot of symbols and equations and formulas, and we think it is an endless world, but we want to change this perception to some geometric perception. When these mathematical problems we see from geometrically, no, then what will happen, it will be some points, some lines or some surfaces. This will become very easy. So there will be very limited things in life. Actually we face many points, lines and surfaces, that is all, and all the mathematics are related to that. When we convert to the analytical calculations, then it will become huge number of formulas, huge number of equations, but it represent a line or it is represent a surface. So we will be doing that, and we will learn how mathematics can be easy if you learn from that perspective. So this is our main objective, to change the perception of mathematics. And another problem what we fail is that we live in a 3D world, but we do not have any tool to, because everything whenever you can see that whatever I am presenting, it is a 2D flat plane or surface, and what we are presenting, it is a 3D cube or 3D objects. So, this conversion, this is most difficult thing in mathematics now, and what we have done, we have solved this problem. We can now convert any 3D object in 2D without any coding or any programming. So, any student can do that with Excel. So, that is our innovation. We can claim credit for that, because this knowledge was known to everybody, but how to do it in without programming was not many people. So, with that we have established our Matlab. Matlab is a company who is working solely on popularizing and promoting mathematics. And today's background of this calculus workshop, actually you can see that we are a company, and entering into a education field is very difficult. And today we are sitting in this TV studio, it is very costly affair, huge cameras, lights and other infrastructure, so many executive and professionals are engaged to set up the sound, mic, light, everything. So, all these are possible for a startup company to do that, because of our visionary leaders like that. Our Prime Minister, he has flagged this startup initiative. So, startups are getting lot of prominence, and as a result we can conduct all these workshops in education system, also being a company. And there is also our honorable Chief Minister Bhupendra Patel ji, he is doing lot of things to improve the ecosystem of startups, and at the same time our Education Minister Jitubhai Baghani ji, he has very kind enough to allow us to do many workshop, conduct workshop, and we have given few schools and colleges to implement our new technology. So, actually what problem I am trying to solve? Problem that we are trying to solve is that difficulty in learning mathematical concepts. This is the problem. Every student faces this problem globally, whether it is in India or Pakistan or in London or US, UK, hardly matters. Every student faces this problem, and we are solving this problem. What we are doing, we convert all those mathematical concept into geometrical shapes, and when we can see this visually, the concept will understand mostly any concept. So, and technology we use is Microsoft Excel, which is very easy to handle, no coding, no programming knowledge is required for that. So, with this we have started Matlab, and this Matlab objective is to be world leader in simplification of advanced mathematical concept. Here we are not doing any research on mathematics, fundamental research we are not doing. What we are doing, whatever the known knowledge of mathematics is there, we are trying to simplify that. If I simplify that, then I feel a student like Mandar, who is just 13 years, I think he can also understand all this advanced concept, and you will not believe that Mandar knows much higher mathematical concept in already at this tender age. And I see him as a budding scientist, future scientist of India. He is doing lot of work on that. And I have conducted many mathematics workshops, but we have not conducted calculus. First time we are doing calculus. So, and the tools, what are the tools teaching mathematical concept in applied way? These are the tools. So, you have to just learn three things. So, one thing is that plotting graph in MS Excel. Today I will do that, how we can plot a graph in MS Excel, and then matrix multiplication, and then creating animation. These three things, and all these thing we will be doing in Excel and without much a problem. If you learn these three things, then I think you will be through in solving any mathematical problem, whether it is mechanical engineering related, science related, physics related, chemistry related, anything you can do, but this basic tool is these three. So, actual problem what students face, they learn so many things they learn, but they never test it. So, this is the tools from which they can test every concept, and today we will be teaching this calculus also using these tools. I will demonstrate in second session. I will be explaining these tools how to do that. And this I am giving some example of teaching mathematical concept in applied way. Applied way means application of the tools what I have mentioned earlier, and how we can use these tools in learning mathematics, physics, engineering, science. Here I will be giving some examples from different fields. From mathematics, I will be giving an example of modeling of differential calculus. Then from physics, I will be giving a modeling of projectile. From engineering, modeling of Watt's mechanism. Environmental science, modeling Lorentz attractor, and which is a 3D phenomena, and similarly nature modeling in fractal geometry. So, I am giving some example where we can use. You can see that these topics are diverse topics in not related to each other, but the tools we will be using are common tools. So, that is the beauty of that. So, if a student acquire the knowledge of these tools or gain understanding how to use these tools, he will be master in any fields where he want to be master. So, you can ask that why we require a new modeling system or new technique for learning mathematics. So, for this my answer is that earlier world, when I was young, when I had schooling, then the world we used to live and present world is entirely changed. Changed in the sense we have lot of technology. You can see now so many technologies I am sitting here, but 30 years, 60 or 70 years back, 100 years back, it was even not thinkable. I am talking to you, and it is being communicated throughout India. So, it was so easily can be achievable. So, all this happening in current world, and we are not taking this advantage in teaching mathematics. So, my suggestion to all the budding engineer, scientist, mathematician is that now there is technology available. You need not solve problem. Earlier in my time I had to solve it manually. In solving 50 calculus problem, it took at least 3, 4, 5 days. But now you can solve 50 calculus problem in half an hour with technology. So, technology is there. Now, you have to learn the concept, how you can take advantage of this technology in solving your problems. So, this is the motto of learning this or organizing this workshop. So, what are the tools available? One of the tools available is that MS Mathematics. MS Mathematics is developed by Microsoft, and it is freely available. It is not chargeable. So, very nice software. There are a lot of softwares, but I have seen MS Mathematics is very good for school and college students. All the mathematics you can solve with that. Then there comes Matlab, there comes Mathematica. These are Scilab, GeoGebra, Google Calculator, like that a lot of things are there. So, they can help you in calculation, but you should know what to calculate. So, this is the change world. Earlier when I used to read, I used to take some calculus problem, I used to solve it, and when I know that how to solve it, I learned it. I was not bothered about the concept, what we have done, what for we have done. But now you can concentrate on that, why we are doing that, why we require calculus or like that. So, because calculus solving, there are a lot of technology with this. So, I have given some example of this earlier days, how a student used to read, and now present days there are so many gadgets, pupils, and sometimes we use interchangeably many things, many and in that communication also, Wi-Fi, Bluetooth, so many options, LAN, and many other things. So, the world has changed, and we should also change our learning pattern also, or teaching pattern also. So, coming back to this Microsoft Mathematics, this is a very good package. You can use it for calculus, for linear algebra, statistics, trigonometry, everything you can do that. And this is also a very good package for graphing. So much, so beautiful graphs you can create with ease. You just give the formula and it will plot for you. So, this is available free of cost, we can take advantage of that. Then there are Matlab, we can do all differentiation, integration in Matlab, just single line code will give you the results. And Matlab is paid one, but there are open source system also, Scilab and other things which is free, and you can use that also. And these are the differential integration, different methods are there in integration and differentiation. Here sometime you can only put the coefficient and it will create your derivative and integral, all those things. So, this I have shown one example of that vectors. Vectors here p is equal to 1 1 1 is nothing but the coefficient of a polynomial of power 3. So, x cube plus x square plus x plus 1, this is the actual polynomial, and if we give dp is equal to polyder p, then you will get a value 3 to 1. So, it is 3 x square plus 2 x plus 1, this is the derivative. Similarly, if you give same p as a integration, so it will be poly int, and then you will get the coefficient of this. So, 1 by 4, 1 by 3, 1 by 2, 1, 0, all these are coefficient of x to the power 4, x to the power cube, x to the power 2, x and lastly constant term. So, like that, and polynomial differentiation and integration can be done by matrix method also, means in matrix method, in the sense you can use it in Excel. So, Excel also you can do that. I have shown some examples here. I will not elaborate here, I will come back again in later phase of our sessions how to do this. These are the yellow is a matrix, and blue color another one column 4 row matrix, and when we multiply these two matrices we get 1 2 3 what is the result coefficient of the polynomial for which we have calculating the derivative. So, like that we can integrate also using MS Excel. So, these are the powerful things, these are the codes we can we will try it. So, now we should what we should focus on, that we should focus on why we require calculus. Calculus there are tools to solve for you, but you should know more about why we use calculus. So, here I will stop a little bit, and I want that you if you have anything about in your mind what is calculus, why we require it, can you find anything anything in this studio which is related to calculus? we have lot of participant. We have Rasikalji, 79 years of age. I am very happy, and beside him he is a Mandar. Mandar is very young boy. I think his age is 13, and he is homeschooling. He is not going to school. He studies at home. So much a diverse audience, and we have petroleum engineers. You also petroleum engineer, and your background? BSc Math. Which college?
Bhavan's College.
Bhavan's College. So lot of things. Can you correlate anything in this room which is related to calculus? So it is practical way of learning calculus. We should see everywhere why we learn calculus. I should first question myself why I require to learn calculus.
Anywhere we are trying to get a sense of the rate of change. That is where we need differentiation.
Okay, rate of change. Nothing is changing in this studio, so calculus is not required here. Mandar, any? Have you thought about anything before? No? Okay.
Maybe the using camera, like it's recording.
But again, still it is not exactly directly related to life. आप कुछ बता सकते हैं? BSc मैथ. आपका क्या नाम है?
Jigar.
जीगर. ओके, जीगर जी आप बताइए.
Sir, there are so many surfaces, so calculus can be helped measuring and cutting and shaping.
Measuring के लिए we have this scaling. We can measure the length. So this is the thing. We learn calculus without knowing the purpose of calculus. And I think if you learn, we talk about that math is everywhere, but we never can see the math is everywhere. Where is math? But nothing is moving without math. Even I am talking, that is also related to so many mathematical formulas and equations. The vibration follows some rules, patterns, and everything. Nothing is happening without mathematics. So, but we cannot able to correlate it. So I should say that calculus, first thing, calculus we try to find derivative of a function, is not it? In calculus we try to find the derivative of a function like that. So actually any function, or forget about function, in layman's sense, why is a line? Okay. Calculus. Any line, even this scale, it is having this edge. Edge is a line. This edge is a line. This edge is a line. This edge is a line. So where is a line? And there are so many shapes, and all these shapes have a boundary, and this boundary all having a calculus. So what is that calculus? We want to know the inclination or slope of these lines, is not it? So what is the inclination of this line, this one horizontal line? 0. It is not inclined, it is horizontal and it is vertical. So it is having slope. Here slope is 0, here slope is infinity, sort of thing.
Sir, in that case, don't you think that this is arguable?
Arguable in the sense?
Like we can measure the angles only. Why we need to attach that terminology calculus?
Yes, trigonometry we do that. Yes, but trigonometry do not give you the derivative slope of the line. It gives the angle tan theta. It gives tan theta.
That is the slope.
That is the slope. Yes, you can derivative. You can directly get the slope. You get the tan theta. You don't need to go to trigonometry. So any line here you see, every line has a attached tangent line in it, it is attached tangent line in it, and it is having some calculus. Okay. And without knowing this also, many people do not know trigonometry, many people do not know calculus, but still there is no problem, because we are born mathematician. My research finding is that humans are born math literate. Humans are born math literate, they know math already. So, in their life, when they face any problem, they do not feel any difficulty in, they make some arrangement to understand or measure this inclination. Calculus was not there in pyramid when they have created, even for Indian this Vedic period, they were constructing so many items for performing many rituals. So, that Vedis, all these objects, they are all related to geometry, and many of them require to be slope, pyramid, how that slope should be, how it can be steep, it can be slant, like that. So, all these things, but they are not knowing calculus, but they used to do it. But when you know the calculus, it will give you the additional confidence. Okay. So, these are the things. So, once I tell you that any line have a tangent, any line. Okay. So, from that perspective, what I should say, what is calculus? Yeah. Now, what is calculus? Now, you can see that what is calculus, then simple answer I have. If somebody asks me what is calculus, you can see these books of calculus. These are the calculus book, and I should say you that it is not complete book of calculus. You can feel that it is so big book, so it is all calculus concepts are discussed here. It is not right. It is also incomplete book. So, I used to read this book, and then I had this book also. This is this book. Then in general, what happened now, there are so many chapters, and when you start reading judicially, very sincerely, go one after one and go on telling, and after you read suppose half of the book, and then you come back here and you will forget everything, when you have to start from new, zero. So, this was the problem what I was facing, and I know. Then one fine morning I was thinking that okay, let me summarize this book. Why I want to read this book? What is written in this book? I have to summarize in one sentence. And that day I really learned calculus. Before that I was moving first page to last page, and it was not useful for me. Every time I used to forget the formulas and ideas, why we are learning those ideas. But when I got that summary, this written, calculus is the story of two lines. So, what is the two lines? Any line, sorry, it can be a straight line, curved line, any line. So, calculus is the story of two lines. So, this line is the first line, and each line have a tangent at any particular point. So, if it is a straight line, suppose it is a straight line, this tangent, whatever point I take, its tangent will be same for throughout. But the problem comes when the line is a curved line, then the tangent which touches it at one point. Actually, tangent line is the line which touches the line in particular one point. It should not touch in 2 points. So, this is the curved line, then this will be actually so here actually. So, what is this two line? This is the one line and this is the tangent line. So, whatever written in this book is this only. We have used these ideas to many other places. Basic idea is this: integration, differential equation, all those are secondary, but everything starts here. And this is the thing. Here we start set, we start relation, we start function, relation, then function, then continuity, then limit, and that makes us confused. Why we study limit? Why we require continuity? What is derivative? Why we use it? All those things. Then it comes many other things also. So, as we will discuss all these things in later phase. So, I was talking about modeling. So, modeling is this. So, this calculus and these are the thing I have shown this story of two lines, differential calculus. Now, as I told you that calculus starts with number system, then we learn set, relation, function, continuity, limits, derivability, differentiability, sorry, it is differentiability, and then differentiation, integration, series and differential equation. Almost these are the broad aspect of calculus, and we will learn it in macro level. Macro level means general understanding why we require differential equation, why we require integral, why we require differential calculus, why we require limit. We will try to focus on those points. Okay. So, these are the some examples I have given where limit and continuity matters, and these are the modeling tools. Actually, when we try to model what happens, this also we can create this model and we can see the effect. So, this modeling tool mainly we will learn today. And this example is from physics. Physics, you can see that when we study the projectile motion, no, then we are being taught that when we throw an object at vertically, it will reach maximum height, and when we throw it at 45 degree, it travels maximum distance. So, the natural question comes, and it was innocent question, and it appeared to me also. I think many people of you also face this question. I do not know means whether it is universal or it is specifically one to person, because I was thinking when I throw it horizontally, so it should travel maximum distance. Why I means if I throw 45 degree, it has to travel up and then it has to come down. So, it should travel less distance. So, if I throw horizontally, it should travel maximum distance. Anything you want to add, Mandar? No. So, have you any answer now? What is that? Can you take this mic?
Hello. Yeah. So, sir, I used to wonder the same thing. So, basically, what happened was, so at 90 degree, it's going straight up. So, it's traveling maximum distance up, and at 0 degrees, it's going straight forward. So, it's traveling. So, it should travel maximum distance forward. But the problem is, let's say from ground layer we are throwing something. If we throw it straight up, it will go as high it can, and then it will come down. If we throw it at some angle, then the force we are putting, it is also going into making the object go forward. So then it will achieve less height and it will go forward. If we throw it horizontally, then what will happen is eventually it will fall to the ground, because now all the force is going into letting it go forward. So it will just fall to the ground very fast and it will achieve no
Why
height.
it will fall to the ground?
Because sir, it won't. So let's say we have our object we are throwing at ground level, right? So if we throw it straight forward, then if it won't go up, then it's like it will fall to the ground only. So it will go forward.
Actually,
it should
any
go.
object. Okay, thank you. Leave your phone. Yeah, it's okay. You want to say something? Yeah, please. Yes, 100%.
Sir, I believe that if you are throwing it at 0 degree, so it can travel infinite distance. There's no question about it. But because of the friction that will get from the ground, that will stop it at
No,
a very...
where is ground? I am throwing air in air, no?
Okay.
Not ground. I am throwing horizontally.
But then again, gravity will pull it down if you are...
Gravity everywhere pulling, no?
But if you are throwing it like this, then there's the friction that will stop it somewhere, which will not be the maximum distance.
Is not the cause actually. Anyhow, keep it there. Actually, this is there is some confusion, is not it? I want to emphasize on that. We are not sure why it is a maximum distance in 45. There is a question of doubt. So I had also, but when I done this modeling, no, then I realized the effect. The gravity pulls it, but when it is horizontal, all pull is directly here. When it goes here, so pull is being have horizontal component and vertical component. So it goes to some extent more and then it falls. Otherwise, it will directly come down. So I could understand it when I modeled it. Otherwise, I have to accept what sir said. And it was I was carrying throughout my academic career and professional career also. I had a doubt in that theory, but when I learned this modeling, no, I almost after few modeling I have tried this. So why it is not maximum distance at 0 degree, and then I realized the effect of gravity. Because effect of gravity, we never feel it. Newton told there is gravity, but we never feel. Where is gravity? We see everything falls down, but still we don't feel that it is gravity is pulling it. We are being stuck with this earth due to gravity, but we never feel it that somebody is pulling us. Somebody is not, it is not binded by rope, no, somebody is binding us to the earth, and not like that, no. Anyhow, so these are the things. Modeling gives you greater understanding, in-depth analysis, and you can go on creating your own thoughts, own ideas, you can go on adding anything, and these are the things. And this is Watt's mechanism is a mechanical engineering problem, and it is in kinematics, and I think class 11 we study in physics kinematics, and so many formulas we learn in HS higher secondary and afterwards engineering also kinematics. But modeling, unless until you model it, you will not realize the difficulty of this. Apparently, you see one crank is rotating and it is rocking, it will appear very easy thing, but when you mathematically model, then we realize how difficult this modeling is. Telling is explaining is with theory, you will never understand the gravity of the problem. So now this is another example of Lorentz attractor. It is generally used in where it is used, you can say, in forecasting, weather forecasting. So, in weather forecasting what happens, why there is a storm, why there is a wind, where how temperature and pressure related, and how we can forecast whether there will be a rain tomorrow or not. All these are related to environmental science and weather forecast. And this there are three basic differential equations are there, and when we solve those three differential equations, we will get the 3D graph like that. And it has lot of material. Orange attractor, if you give in internet search, you will get all these things. And this is a 3D phenomena. One beauty is that this will confine in this small region, and no curve ever cross any other curve. It moves in 2D, some vertical plane, then it goes to the horizontal plane, again come back to the vertical plane, like that it goes on, but it never cross any curve each other. So many important characteristics are there in low range attractor. And now nature we generally we capture the nature's problem in fractal geometry. And fractal geometry, it is a beautiful subject, and we hardly learn anything about that because it is being so difficult to learn. But in other perspective, you see this when we do modeling of this fractal geometry, then it will appear very simple. What we have done here, we have created a fern, and it appears that any artist has put some dots and it has been created, but it is not like that. It has been created by randomly taking points. I have taken some points randomly with random probability, and then plotted those random points and one after another. So, this random generation of points also you can see that how regular fern leaf has been created. So, in nature also, nature's anything is not being created, everything get created randomly, nothing is regular, is not it? There is no machine shop in nature, and everything forms randomly, but everything having some particular shape. When you see a river, fountain, cloud, you can easily identify. Fire, all these are nature subject, no? Fire has its own shape, cloud has its own shape, but these are not factory made. This is randomly happens in nature, but though it is randomly happening, it has a clear shape. So, this is the beauty of mathematics of nature. So, there also lot of mathematics is involved, and it is a depiction of that. This fern I have created, this has randomly taken the points, and this randomly taken points ultimately they have produced a. So, this randomness is not chaotic, it gives a regular shape. So, this is the ideas of basic ideas of fractal geometry. Then there are many other ideas are there, but all based on that observation. This random here also something two factors play important role, or though in nature's geometry. That is, one is that it is self similarity. When you have infinite differentiability and self similarity, means if there is an object, you can divide it in as many number times as you want, and every time you get a replicate of that, similar object of that. So, first definition, when you learn this definition first time, you will think that there will be no object like that, which you can divide and it will retain its own shape. But nature is full of such objects, and when you start practicing fractal geometry, you will realize everything is fractal. Fractal geometry in the sense it dimension, what we are habituated to see is one dimensional object, 0 dimensional object point, 1 dimensional object is line, dimensional object is a plane, 3 dimensional object is a solid, like that we are habituated. But can this dimension be 0.2, 0.1, 0.1 like that? So, answer is yes. There are dimension which is not integers or natural numbers, not 1, 2, 3, 4. There can be 1.2, 2.5, 7.8 like that. There can be dimensions. So, these are all the domain of fractal geometry, and these are the things. And similarly, I have created some objects. These are the trees I have seen. I was staying at Bombay Institution of Engineers guest house. So, I have seen a bush like thing, a plant like that, and similar shape to this. And then I thought I was knowing how to plot these points and randomly, and we can get a regular shape. Then I tried something, and we start getting this. This you can say this many of the plants you can get like that, but it is created in MS Excel. So, with that I went to that Institute of Chemical Technology HOD Mathematics. I met him, and I have shown, you see, this is the bush, and I have created it in Excel. So, he was so impressed that, sir, we will conduct a workshop here. So, he conducted a 3-day workshop on mathematics at Bombay. His name is Ajit Kumar sir. So, with this you can say that this modeling tool actually plays a important role in any subject, mathematical, scientific, engineering, technological, medicine, everything. And one another thing I should say, that medical science is improving because of mathematics. Mathematics is improving, and mathematics, with mathematics, electronics is improving. Means whatever we are thinking in mathematically, there we can create a device which can convert it into the reality. So, mathematical formulas are used, and then we are imaging CT scan, all blood groups. So, whatever maybe you can say that everything involves huge mathematics, and this we can get a better treatment, better understanding or diagnosis because of the mathematical tools in science. So, many students they switch to biology or go to medicine due to the fear of mathematics. But I think if a mathematician goes to medicine, he can perform better than who is in biology background. So, these are the things. So, with that I think coming back to the pavilion 0 point, that there is tool, you need not bother about tools, and you have to know what to calculate, how to calculate. You have to instruct that if you think that your laptop is your servant, you can have the knowledge how to instruct it, and it will perform for you. And here is a debate, that what is the debate, whether school students are permitted to use laptop or not, and this solving problems with technology, or they should engage with their mental ideas. So, many schools do not encourage students to use technology. They think that they should learn mathematical concept as a mathematician, and many college they allow students to use technology. So, the difference where it makes a difference is that when they go for exam, no, board exam or competitive exam, then there are two distinct division appears. Those students who manually solve the problem, they could hardly solve 10 to 20, 30 problem in a day, and those use technology, they can solve 200 to 500, even they can finish the chapter in one go. So, they know and they can graph it. Those manually, those are practicing, they cannot graph it immediately. So, they cannot understand the graph of those functions. So, they are always in receiving end, and those are practicing with technology, they are scoring high, their understanding is growing more, and they are going to IITs, IISIR or other premier institute. It is brilliance is required, but the approach also make difference. And this approach, I will say that another story, how it affects a individual. I have given an example as an example student, but how it affects to the country as a whole. Now, you can think of the Newton's period 1600 1700 AD. That time 300 years back, then Newton developed calculus, and that time all you know that England was UK or England was superpower. They are dominating the world. They made colony almost everywhere in this world. So, how they could successful? They were successful. Why? What was the extra advantage with them? Can you say anything? Why UK was dominating British? British was ruling us also, no? So, what was their power? They are much advanced in science and technology, okay, than others, and they used to do a lot of things in science and technology. Then came the era of Newton. Newton, when came, he devised calculus, okay, and parallelly Leibniz also devised calculus. And there was also a case that Newton used to feel that Leibniz has stolen his material, but it was proved that it is not like that. Both are working in different ideas, and both they are attributed that they are the founders of calculus. So, anyhow, that is a story. So, Leibniz was also developed calculus, Newton also developed calculus, and England took Newton's ideas of calculus, and they used in their technology and books. But USA and some other countries, they took the ideas of Leibniz, that too also calculus, and the end result is that England was 200 years back in science and technology than the US. One approach. You can think of the gravity of that. So, those students are not using technology now. I will say that he is not of that much use, and who is using technology, when he talk, his attitude, if you see him confidence, then you are a very smart boy. So, that is making the difference. It is not that they are intellectually they are very different. Intellectually they may be same, but the approach they are adopting in learning and teaching mathematics, that making them up and down, up and down. So, my first session, my suggestion is to that you all use start using technology to solve your problem. Once you start using MS Mathematics, I can guarantee you that you can solve 70, 80, 90, 100 even depending on your concentration level, you can solve 100 of problems in one day, and you can get greater insight into the subject. without manually seeing the pattern, seeing the insight, the depth, it is not possible. Because we are not means if I have to be Newton, even Newton require 500 years back support to get the Newton's laws of motion, no, all those things. It is not readily created. So, we also cannot create anything overnight, we cannot learn these ideas overnight. So, it is required a lot of in basic ideas, and based on that you can go ahead. So, who is being using technology, they can move much higher speed and reach a higher level. So, this is my first session. I will be breaking now, and after 15 minutes we will come back and again we will start our second session, and that will be practical session. We will do something with calculus, with how we can create a derivative and all those things in MS Excel. Okay. So, we will break now. welcome back. This is the second session of our workshop on calculus in MS Excel. So, my message to you all that you start using technology in learning mathematics if you really want to excel in your academic and professional career. So, that is one thing I want to suggest you from my experience. And now I am switching back to my core subject is calculus. So, let us have some thing about calculus, and before starting let us scan the mathematics that we require to learn in class 1 to 12. So, what are the mathematics we learn and why we learned it and how much we should learn, all these things are there. And we should have a clarity on those things. In isolation, I study something math in class 1 and then forget, and then again learn something in class 2 and forget, and then it goes to up to 12, and it will not help. Actually, these 1 to 12 courses are prepared with very renowned mathematicians, scientists, sociologists, and many experts in their respective fields, and it was very nicely created. Particularly, I am talking about NCERT books which I follow, and from there I tried to understand what we require to learn from class 1 to 12 and how. So, this session will concentrate on something, and from there we will try to extract that how the calculus are being introduced. So, with this you can see this is the chapters of NCERT book, and in class 1 there are 13 chapters, class 2 15 chapters, class 3 14 chapters, like that. Almost average 14-15 chapters are there in each year, class 1, class 2, class 3, class 4, like that, and total chapters are 182. So, 182 chapters we are required to learn and these chapters are not in isolation, all these chapters has correlation relation. It requires class 6 up to 5, class 5 we require all the knowledge to study the chapters in class 6. So, I have tried to scan that also, and in my study you can say that I have given some coding, color coding in my subject. These are the broadly 29 broad topics what I have seen in class 1 to 12. Broad topics is 29. It can be squeezed a little bit or it can be expanded a little bit, but broadly it is 29 topics. So, what are these 29 topics and when we are required to learn that? Once you have all this clarity, then mathematics will become very easy subject. Now, you see that first I started with geometry, and that is the pattern in mathematics book in NCERT. NCERT math book also start with geometry, not with numbers. First chapter is on geometry. So, then geometry goes on, we go on studying geometry from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you will find that the importance of this geometry. And many people tell that, sir, after 10 there is no geometry, but that is a wrong impression. I should say that after 10 whatever we study, all the subjects are geometry. So, that we name it coordinate geometry, we name it trigonometry, we name it calculus, or we name it abstract algebra or linear algebra, anything, all are geometry. So, you can find the importance of geometry. Then second chapter starts with number, and you can see this fascinating fact that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all these numbers we go on reading, and you can realize the importance of numbers, and we give least importance on numbers. We feel that we know numbers, but actually we do not know numbers, and that is one of the reason that where we face problem in learning mathematics. So, number system starts in class 1, goes up to 11, and after 11 also I should not say that number system stopped there. After that we learn that vector algebra, complex algebra, and matrices, all our group of numbers, those are also quaternion, octanion, and other many other topics are there which is involved in handling numbers. So, number is also so important. Then arithmetic operation we read up to 1 to 5, that addition, subtraction, multiplication, division, all those things, and measurements starts, and money, statistics start at, you can say, data handling, point number 6 up to 8, data handling. Actually this is the starting point of statistics, and then pattern and symmetry, that also 1, 2, 3, 4, 5, 6, 7. So, after that symmetry and pattern, these two are very important topics, but I do not know why in higher classes they are absent. I think there should be some advanced pattern on symmetry on topics in symmetry and pattern. Anyhow, so rest class 6 you see we start algebra and mensuration. So, what I can say that measurements we are extension of mensurations, and then it starts from class 6, ratio, proportion also. So, these are the 10 topics. First group we start class 1, second group we start in 6, and then this is the third group. Third group starts in 9, coordinate geometry, statistics, probability, proof of concept, and mathematical modeling, all start in class 9 and goes up to 12. And fourth group we can say this is trigonometry, set theory, function, limit, derivative, that starts in class 11. And last groups are this differentiation, integration, differential equations, these all are taught in class 12, and with that matrix, determinant, vectors, linear programming also that starts in class 12. So, in that perspective, if we see this calculus is introduced in class 11 and with 6 chapter, total chapter is 18 in class 11, mathematics chapter I am telling, and 1/3 of them are related to calculus, and in 12 15 chapters are there, out of that 7 chapters are on calculus. So, you can say 50% chapters are on calculus in class 12. So, these are shown graphically. So, there is no chapters in class 1 to 10 in calculus, but there are 13 chapters in total in 11 and 12. So, one student if they learn this 13 chapters properly, they can learn the calculus easily. Then in that 6th chapter I have taken 4 chapters that is directly related to calculus. These chapters are sets, relation and functions, and limit and derivative. I think I should not generalize. My opinion is that the confusion of learning calculus starts here. These are the separate chapters, sets, relation, functions, and limit and derivatives. So, students learn these topics in isolation. In isolation, what I mean to say that when they learn sets, they concentrate on sets and they solve many problems related to set. Then they start relation and function and they forget about the set. So, that way how the set is related to relation and function, they face difficulties in understanding that, and then how this function and relation are related to limits and derivative, that also if we learn in isolation it will create problems. So, this there we should we can do something for improvement. Anyhow, my approach will be entirely different. So, I will be going that way. And these are the chapters in class 12. There are 6 chapters in general. I have excluded one chapter intentionally, which is not directly related to calculus. I will tell that about that in later. So, here also relation and function we start, continuity and differentiability, then application of derivative, integrals, application of integrals, and lastly differential equation. These are the broad topics of calculus, and one for me, if you understand this concept and solve one problem for each, you will be having good confidence on calculus. What we try to do, we try to take one chapter and we try to solve 100 problems on that without concentrating on what for we are solving those problems. So, until unless you understand the what for we are doing, it is very difficult to understand calculus. This is my observation. And this plot activities related to calculus, what is to be done in calculus if you clearly understand these 4 activities, this related to calculus: plotting a graph of a function, calculating the derivative or slope of the tangent line at a point, calculating the y intercept of tangent line, and plotting the tangent line. So, if you understand these 4 steps properly, I will teach this 4 step how to do that. Once you do that, then you can say that 1/4 of calculus you have learned. Only thing you should learn it with very clarity. Now, I am these are the basic thoughts of calculus from my side, and now I am going that broad topics of calculus. What are the what we require to learn in calculus? So, broad topics, if you see this, we can divide the total calculus topics in these 4 groups. One group is that differential calculus, integral calculus, differential equations, and lastly series and sequence. Here this series and sequence, many of our students and faculties, they do not understand the relevance of series and sequence in calculus. What they do, they learn a lot of series. We start learning in class 6, I think APGP, and after that we learn binomial series and Taylor series, so many series, but we never understand why we study those series, and this is the another problem in calculus. So, broadly calculus is having these 4 major divisions. One is differential calculus, one is integral calculus, one is differential equations, and then series and sequence. I do not encourage you that you concentrate on solving problem, you concentrate on understanding that what these 4 part do in calculus. So, these are the things, and if I go for this integration topics of calculus in class 11, chapter 1 having these topics, they talk about many ideas of sets, and they are these are the things, but I am not going to talk on details on these topics. I will tell the relevance of these ideas in with respect to calculus, and these are the second chapter, which is relation and function. It has 4 topics, that Cartesian product of set, relation and function, and similarly limit and derivative. These are the 5 topics in limits, limit of trigonometric function, derivatives, all these things. And then again in class 12 it starts with type of relation. Earlier we have studied relation, and then type of relation in calculus, and type of functions, then composition of function and invertible functions, and binary operation of functions. So, these chapters you can say mostly deal with functions. So, function I will describe how to create in Excel, different type of function I will create. So, this chapter 1 of class 12, which the limit and derivative, they mostly concentrate on functions. So, next is application of continuity and differentiability. So, why continuity is required, what is differentiability, then other functions and their derivatives. These are the things, mean value theorem and other application. Lastly, we work on this application of derivatives. These are the things, how tangent, normal, maxima, minima, rate of change of quantities. Just I am sharing these topics that we require to learn, and these are the integral, introduction to integral, and these are the topics to learn from in this chapter, chapter 7. Lastly, introduction of integral. Then chapter 9 is application of integrals, how we use it for finding the area under simple curve. Then we use it for finding the area bounded by a curve and a line, and then area between two curves. So, these are the broad topics, and lastly we talk about differential equations and what is the topics involved in that. And lastly, these are the infinite series, it is included in class 11 in as an appendix. So, many students fail to learn what is the requirement of this series or infinite series. So, we will talk something on that, and now I am going to this whatever we have discussed, it is all about functions, and these functions can be again a very big chapter. I have books where a lot of things written there, and there you will find many of the chapters like that. I have categorized this chapter, this algebraic, transcendental, then algebraic function also can be grouped in polynomial, rational, irrational, piecewise, like that. There are constant polynomial function, again sub category, constant, identity, quadratic, cubic, even, odd, like that. Then rational functions, it is the ratio of two functions, rational functions, like that, irrational functions. So, piecewise function, transcendental function, again trigonometric, can be exponential, can be logarithmic, implicit functions, like that. So, whatever I should say, that this whenever a function comes, this is the thing. If there is a function, then there is a line. So, I have shown so many functions, but if you see that geometrically, algebraically those functions, or there can be 100 of functions like that, but geometrically that can be some lines like that. Some function, any of this line. So, all the function represents a line, and all the lines represent a function. So, broadly you can see that whenever you see that line, then there is a function. Even all these straight line, y is equal to mx plus c is a function, is not a straight line. So, y is equal to x square is a quadratic function. So, like that all the function and line, but there is one barrier. What is that barrier? Suppose I have a circle, but this circle is not a function. Okay. we can represent it as an implicit function, but the one set is required to be function if it has for all x one y, it should not have 2 y value. So, in circle it is for 1 x there will be 2 values, no. So, though it is a line, curved line, circle, but it is not a function, that is a limitation. So, another example is that suppose I am moving my car in this fashion. Here also vertically I have crossed vertically at 3 points. So, it is also not a function. Okay. So, but this is a line, this is a curved line. So, this curved line should have a tangent line. Tangent line is associated with any line, it can be curved line, it can be a straight line, but this curve is not a function, but that does not mean it will not have a tangent. So, all these lines will have a tangent, it will have a tangent. Similarly, it should have a tangent in every point. So, how this is represented by something x square by a square plus y square by b square is equal to something like that. But these are called implicit function. Implicit function is that there are two types of function, implicit and explicit. Implicit means all the polynomial function is called explicit. I am taking you in a complex path, but just example. Explicit function. Okay. So, explicit function is y is equal to x square plus 2 x plus 1, and implicit function what is the difference between these two? That we know that this y value is dependent on exclusive dependent on x. But here we can write this function, we can write is as a x is equal to 1 by y. So, here we are not sure who is dependent on whom. So, that is why I call it is implicit functions. Okay. That is the difference. Actually, this is a definition problem, but it is also a line, this will also a line, and this will also be a line like that. So, these are the subtle difference. So, first here and then there is a line like that. So, this is also a line. So, here we cannot express as a function. So, what we do here? We do is a parametric function, parametric function. So, parametric function can be dependent on a parameter. So, x is equal to suppose t is a time t square and y is equal to t cube. So, then this x and y we can take some values, and both are dependent on t, and this type of function is called parametric functions, and it will also have tangent line. Means when there is a line, there is a tangent. We are in calculus, we try to find that. Here also this line is like that function, and we are interested to find this line, tangent line. Then again some point, suppose you have a plane like that, and you have a polar coordinates, you are working with polar coordinates. So, polar coordinates here, suppose this is a point A, it is also x and y, it is having x and y, but we do not know x and y, we are moving in a polar coordinate. So, x is equal to suppose r cos t and y is equal to r sin t. R is this distance from here to here. So, this curve can be like that, moving like that, depending on r and t. So, there also we can have, it will also have some tangent line. We have to find some tangent line in different points, how it is moving. So, here actually these are the thing. So, whenever there is a line, whether it is a function or not, it has to be a tangent. So, entire book it is some few chapters are in explicit equations, few chapters in implicit equation, few chapters in parametric equation, few chapters in polar equation. So, big chapters are there, but overall you can see that all the functions represent a line. So, when you think of in future, when you think of a function, you should think as a line. Any function, it should be function of one variable, that means it is a line. If it is two variable, then it is a surface. These two, and more than two variable, that geometrical interpretation is difficult. So, these are the things I wanted to share. Now, I will be going for practical aspect, how we can do all those things very easily. So, for that I will be doing this exercise, and if you can note down how we do it. And one example I will give, then I think it will you can do it for others. Function 1, I am plotting a function 1. So, is it visible? No, I think this is okay. So, this function is y is equal to x square. So, we require some x values to plot this function. So, x values I will be plotting in B5 and y values I will be plotting in B6. So, I will be starting with a point, how to plot a point. I think many of you know it, but I am just for clarity sake I am explaining this. In insert scattered, I will be using this scattered chart mostly 70% of cases we will use this chart, scattered chart. And you can also learn this plotting from internet, it is very easily available. You should concentrate on the concept, ideas. So, here when I plotted, you see this, it has plotted a line. This is first problem we face. So, select that line and delete it, and right click on this, and here we get a option for select menu, select data, sorry, this menu item having a select data. So, you click on select data, add, then here you get a option for entering series name. So, here function 1 you can write, and then series values you can put it, you can right click on this red mark and you can select x value here, and then you can select y values and this. So, you can easily plot this 3 and 5 and right click on this, then you can label point add data label. In this menu, right click on that and you will get add data label, and whenever you right click on it and format data label, so what will happen, it will give the label options. So here you can enter series name, then x value, y values, and you can put it in position it the label at center. At present it is right, so I can put it in top, above, so like that. So it is giving my the point what is plotted here, okay. But this is a point, sorry, point. So I have renamed this sheet as a point. Then once I learn this how to plot a point, I can go for plotting a line. So line is like that. We require 2 points. So x and y, these 2 points we require. So let us take 1.3 and 5 and another point 7 and 3. So can you tell how this line, it will be upward line or it will be downward line? By seeing the data, can anyone tell? Bolo. See that x value and y value and tell. So this line is going down, okay. Again we can add right click on it, add data label, then again right click on it and format data label, and you can add x and this series name also. So series 1. So series 1 you can add like that. Select data, edit, and then here you can select this B3 cell which is line, written line. So you can say that when you get it is line 3 and 5. So it is taken this line as a series name and this point. So you can remove this legend here, and this is the line. So this is the simple technique. You can say plotting is so simple, is not it? So once you plot it, then you go on adding multiple points and you will get different polygons or anything, any object, is not it? So let us think it is a line. I am motivating you to use these simple techniques for doing your modeling and animation. Calculus is one of the use of that. So this line again, in this line you say triangle. Triangle we require another point, so you take it 5 and 7, and this first point and last point to be added, so that it is a closed triangle. So what I have done, I have copied this line and then I have added these points, and now I am clicking on this line, and you can see when I clicked it line, this data point selected. So I am just dragging it up to bottom, so that I include all 4 points here. And now you see this is a triangle we have created. So very easily we can create these objects, and when we try to model it and after that our main problem what we are facing now in mathematics teaching is that part again. You see this creating model is very simple, is not it? Just use put the x and y and then plot it will be, but that model is a static model. It is no movement, but we engineers, scientists, technocrats, doctors, they want to capture the dynamism of the model. The static model is not our requirement. We want to see the many effects, how it can be scaled up, how we can scale down, how we can rotate, how we can reflect, how we can do many other activities, the movements. We want to incorporate that, and that all these things can be easily performed in Excel, and that part I will teach now. That I think 6 type of movements are there. If you learn these 6 types, you can add any of the concept. No, you can transform any objects. Okay, and then later you can animate that also. So we will be learning how to do that. That we can do it. Earlier I have shown 3 things. One is plotting, second is matrix multiplication. So matrix multiplication we can do that, and matrix multiplication we do it in linear algebra. Lot of definition we learn, but the simple techniques we do not learn in linear algebra. So I am explaining that how we can do that. We will be using directly a technique or coordinate system called this is Cartesian coordinate system. No? Cartesian coordinate we are dealing with x y, but we work with a homogeneous coordinate system. Our homogeneous coordinate system, what is a homogeneous coordinate system? It is again another chapter, another point which is required to be explained. You need not learn much about that. You should use to learn the concept. What is this? Because when you drive, no, what is a steering, brake, how it works, you need not learn to drive. You have to use it. How you can use it. So here also something I am telling like that, because if I start explaining what is homogeneous coordinate, that will take another class. So I am avoiding that. So what is that actually homogeneous coordinate system? We use another parameter. So 1 1 1 I have taken a default parameters, and this I will be taking for all the cases. So it is I call H value, and then I will be taking a matrix of, this is 3 columns, no, and these 3 columns, anything I require to multiply matrix multiplication, I require 3 rows. That is the thing. So here I am taking a 3 by 3 matrix, and with that I will be explaining how we can use these simple techniques for all the movements I discussed earlier. So you all know that this is a identity matrix, yellow color, and this is our triangle. Okay. H is homogeneous coordinate. We have taken another component of Cartesian coordinate x and y. H I have taken for particular advantage. So you take it as a 1, means H is 1. It is another element which is different than Cartesian coordinate. Cartesian coordinate having some weakness. I will come after discussing, I will explain that also, why I am using this homogeneous coordinate as 1, and what is the problem of not using that. Now what I am trying to do, I am trying to multiply this, my object I am trying to multiply with a matrix multiplication. So the command is here MMULT. Then this is matrix 1 I have selected, comma, then matrix 2, and then control shift and enter. This is the thing I have got another matrix, and so here so triangle 2 is the transformation matrix. Okay. So, this is the transformation matrix. We can write it here. Transformation matrix. So, this is the right hand side resultant matrix and left side is original matrix. Now, I am taking this matrix and I will be doing some scaling on this. I will be move or copy and create a copy, and then I will be moving it. So, this transformation I am scaling. So, what I want to do? I want to make it bigger. So, how we can make it bigger? If I increase the x value, y value, then it will become bigger. So, how we can do that? Here we have identity matrix, no? Here I can make it 2 and here I can make y values 2. So, in that case it is you see right hand resultant matrix has changed, and if I plot this right hand matrix here, no. This is the x values. So, you can see this new triangle, how large it has become. So, here and it is not required to learn it here itself, because these are all these things available in Google. You can learn it, how to multiply and how to plot all these things. You should learn that if we multiply two matrix, we get another resultant matrix, and so this is new and their corresponding y values are also there. Okay. So, I am taking this and copying this, move and copy, create and then move to the end. So, I got a scaling, another scaling here I am trying to do, I am making 0.5. So, let us see what happens, 0.5. So, you see this is had become a smaller. So, how easily we can increase or decrease any object. So, this is for this I have demonstrated this. Then I am copying this same thing, move or copy, and now we put it again 1 and 1. So, again you see the both has overlapped. So, nothing has changed because it is a identity matrix. Now, if I want to make a reflection of this, so here name change reflection x, reflection y. Suppose y axis is the mirror and I want to reflect it. So, what I have required to do, if I change this x is equal to minus 1, you see this how nicely it can reflect. Simply I change this matrix, identity matrix 1 to minus 1. So, like that. So, if I take this right thing, and this you can make it everything lively. Actually, now we deal mathematics in a static level, that you can change it. That here name ref x. What will happen if I reflect it x? So, I will be 1, and there is no magic. I am changing the values of here I have changed the y value sign, or earlier I have done the x value sign, that is why, and that I can do it easily with multiplying with minus 1. That is the thing we can do. And similarly, now we can create a function. Now you know that how we can apply transformation, is not it? So, now I am creating a function. So, how I can create a function? Suppose I want to create a y is equal to sin x, this function I want to create. So, I have to take some x value. So, x is equal to, you can take any value minus 7, all these values you should take in radians actually, and it will whatever value you give here, your Excel will take it as a radian. So, I am incrementing it with 0.1. I have started with minus 7 and I am adding 0.1 to that, and this is like that and goes to so still it is in minus. So, let us drag it. I am dragging just I am not doing anything else. So, up to 15 radian I am plotting this x, all values are in radian, or here what is the function is the sin x. So, again insert scattered. So, you can see this how nicely we can create, and process is same, plotting process is same, whether I create a line, point and function, all the process are same. Now, we require to calculate the derivative. Sin x, what is the derivative of sin x? Cos x. So, actually can anyone tell how this shape will be of cos x? Very good. Once you start practicing like that, then you can immediately it will appear in your mind. So, we want to calculate dy dx, this is x and this is y and this is dy and then dx and then x and then dy dx. So, what is dy dx? Y2 minus y1 is the dy dx, is not it? I am not using any formula, I do not know the formula of this. So, what I am putting, this is the dy, and if I drag it, then I will get this values actually. And then what is dx? Dx again x2 minus x1. So, this is x2 minus x1. So, now I have to calculate dy dx. So, and I have to plot it also. So, what I am doing, I am plotting these x values here again I am copying this, and then dy dx is I am just calculating from this dy dx. This is dy divided by dx. So, now I have x and y, let us plot it. Now, you see this is the cos function. I was not knowing whether it is a dy dx is cos or something. What I have done, I have calculated same way y 2 minus y 1 by x 2 minus x 1. Slope is a y 2 minus, and let it be. Okay. So, what I have taken, the problems what students face. I think something like that. So, we got this is cos x and this is sin x. Okay. This is cos x sin x. Now, I had a function and I have got another function, but we wanted to find the derivative. So, what is the derivative? Actually, we want to find the derivative at a particular point. We do not want the function, this is giving, but we want that derivative, suppose at x is equal to 1 radian. We want to know the derivative dy dx at x is equal to 1. What it means that I want the derivative of x of this function at value x is equal to 1, and that slope of that tangent line. There will be at 1, suppose this is 1, I do not know. So, this is 1, okay. The sin x value is 1. I want this tangent line, there is a tangent line, I want the slope of this tangent line. I do not want this function of cos x. So, this tangent line I require. How to draw that tangent line? You got, this is the problem. Here actually when we study in book, we do this and matter ends there, but we are not interested in that. We interested in this. We want to find a derivative or slope of a tangent line.
Sir, so at the point, so let's say, yeah, sir, so at the point 1, so we can take dy as, yeah, so we can take basically y at equal to 1 and minus y2, y2 minus y1, so y2 can be. Yeah, sir. So
Can you come?
okay, sir. So I am not sure about this, sir. So this is what I think it can be. Yes, sir. So if this is our line, this is our sine curve, and let's say this is at x equal to 1, right, sir? So what we can do is we can take we can have y2 minus y1 basically. So y2 can be 1.01, so like small difference we can have, and like so that will be a small part of the curve, and then that we can expand, so that will be a tangent line.
Very good. Actually, I will do that. Same thing. So you mean to say that you will take x2 as very close point and then calculate the y2. So y2 minus y1 is divided by x2 minus x1. That you want to do. Actually, I will do that. And when we do that, so I will take x is equal to 1. So x1 is equal to 1, and then x2 is equal to 1.01 as you told. So correspondingly, we have formula. With that formula, we can find that what is the y1, and then from this formula y is y2. So all these things I will be doing. So how we will do that? So let the graph we keep aside here, and we take x and y. So first we require to take x and y, x and y. So x equal to 1, and I will be taking a very small increment. So as Mandar has told 0.01, so I will be taking 1.01, and formula, whatever formula I will be using, I will use this formula. What is that? Y is equal to sin x. So what I will do? I will copy from here and paste it from here. Okay. So you can say 1 is 0.84. Yeah, this is right. Then I will copy it. Copy how? Double click it. So y also I will get, and here I will mark the values as input cell. So what I am doing? I am giving the input cell only these two data. One data is I started interval at -7, and then these are the formulas I am using for calculating other values. Similarly, I am putting this sin value here, and then I am clicking on that, so that it will copy this formula. So So our input cell is only 2. Here also I have taken this is as 1 as input, and corresponding this is the values I have taken. Rest I am calculating. So I am while highlighting, in future also I will be using same worksheet for other functions. So here also dy. Actually, Leibniz and US followed this method in their science and technology, and they progressed, but Newton's method is very conservative. They do not allow this. This is actually numerical calculations, and they go for analytical calculations that are more accurate and classical mathematics, but it is a crude method, but result is almost same. It is less accurate, but you can work improve it by taking very close points. Now, dy dx is equal to y 2 minus y 1 as Mandar told, minus y 1, and then dx is equal to this y x 2 minus x 1, and then dy dx again I will be doing dy is this divided by dx is this. So, here you can say that it is a minus 0.360. So, can you tell seeing this value how this tangent line will be when this dy dx is equal to .5 something else called 0.536. So, by seeing these values can you tell this how this tangent line will look like? What happened in positive slope? Yes. So, dy dx can take two values, or in extreme cases 4 values, if you can say. One is 0, one is positive, one is negative, and one is infinite or undefined, means vertical lines. So, this 0 means horizontal line, and positive means dy dx positive means it is an upward line. Upward line how will identify? It is from left to right you move, then it is upward line, and if it moves left to right it is downward line. So, in all cases you can define that. So, it is a upward line. Now, to draw a line you require 4 points, 2 points, and 2 points has 4 elements. So, any line if you require 3 more minimum parameters to get that line drawn. 4th point you can calculate from these 3, but you require minimum 3 points. So, here we want to plot this tangent line. No, tangent line is a straight line. So, tangent line is straight line, it is having formula of y is equal to mx plus c. So, tangent line formula, tangent line is always a straight line, and it is mx plus c. These are the anything. So, this formula here if you have 4 to plot this line, you require all 4 point parameters or variables you should know, but we do not have. What we know? We know y, we know x, and we have calculated m as dy dx. So, what we do not know? We do not know c. So, we know these 3 values x, y and dy dx. So, c is equal to y minus mx. This is the so c is equal to what is the y value? Y value is this k8 in my case, y minus m into x. So, see now we have all the parameters required, m and c is required, and x we can take any values. So, what we will be doing? We have one point already, this point we have. We require another 2 points or 1 points to draw that tangent line. So, what I am doing? I have taken this x values plus suppose 2 or take 1 value less, and another point I am taking 1 value up, this value plus 1. Now, here the values will be y is equal to m x plus c. So, is equal to this is the x into this is the m plus c, and then is equal to this is the x into m plus c. So, now we got these values of x and y. Now, we want to add that tangent line. So, add, here we can write tangent line, and then x values are this and y values are this. Oh, you got that tangent line here, format data series, and here line style I can make it a thick, and then I can make some arrows in one side, and then we can change the line color. So many options are there, you can exercise so many options. So, this is the here also marker options, none. So, this is the tangent line. Now, you know that how we can model, we can plot and x and y, and we can create anything, and then once we create anything, then we can create function also with that. I have created a function, then I have plotted that calculated that derivative, that also without knowing any formula, and that function also I plotted, and lastly I plotted the tangent line at 1. But you will be interested to know, sir, I want to know that what is the value of tangent of 1.4, 1.3 or 1.7 or any minus 1, 2. So, how we can do that? Because I told you that we are live in dynamic world, you want to know that at what point. So, when you calculate this maxima minima, no, what you see with learn there dy dx is equal to 0. What that it means? It means that where this dy dx is horizontal line. So, you want to know that where is horizontal line is 0. So, you can do it by animating. You can animate, you can calculate for this derivative for any values, not only one, as I have given here in this cell J8. This cell this is 1, and that is why it is plotting 1, but I want that this cell should be changed as I require. So, how we can do that? We can do by animation, and what is required for animation? Now, I will explain that. For animation, you require a tool called developer tool. I think it may not be available readily in your main menu of Excel sheet, but it is available in your menu options. So, you can go for file, then options, then customize menus, and you can tick that developer option, then it will appear. So, this you can try at your home later. So, developer action it is included in my system developer. So, you can see it at top developer, and once this developer is there, then what you will do, here is an option of insert, and there is a option for scroll bar. Here this is called scroll bar, form controls and scroll bar. This scroll bar, when you click, and you can put it anywhere. So, here I will be putting it here. So, you can see this is called a scroll bar. So, scroll bar you can format it by right clicking on it. So, I will right click on it, and last option is format control. It is given minimum value 0, maximum value 100, increment change 1. You can change it, anything you can change as you require, but and then output you can put in some cell. So, I have selected K6 cell to put the output. Okay. So, when you click on this arrow, you see that K 6 values are changing. Are you getting this? I can make it color code. Yeah, 23. Now it is 20. Oh, sorry. You understand that this one, and then what I want, these are all only whole numbers. We cannot put any other numbers, negative numbers or fractions, we cannot put it. So, if you require some negative numbers or fractions, you have to play some trick. So, what I will be doing here, I will take another cell, J cell, and I will make a 13 minus suppose 50 I have taken. So, and divided by 100. So, what I have done, when it is 13, it will be 13 minus 50. So, it will be minus 37 divided by 100. So, minus 0.3. So, and like that, when we get require some positive number, we can drag it. Now, it is when it is 50, then now my values are 0. Okay. So, I can correlate this point, this cell with this point. Now, whatever this is 0 and this tangent line shows the derivative at tangent line or tangent line is at 0. Now, if we go on dragging this you can see this how animation is happening. And you can see this how C values, oh sorry, it is now I have to increase this, you can put it 1000, no problem. So, it goes on animating your at different points. There are many options to increase or decrease the speed. You can take an increment like that. You can see how it was horizontal, then it is this cell is changing dy dx. So, values from this cell you can change, and then you can see that y intercept also. So, like that you can animate any thing if you want to do that. So, these three tools are not very difficult tools, but it will give you a tremendous flexibility on your learning mathematical concept. With that we will break for lunch. Welcome back to our third session of this workshop on calculus, and morning session I have shown many of the subtle or intricacies of calculus. Now, I am planning to explain some of the technologies available for solving calculus. So, first I will be starting with a technique which is very nicely we can do without much difficulties, that is using MS mathematics. MS mathematics was created by Microsoft and freely available. So, anybody can download it. Is Microsoft version 4 is available now in market, and any one I think all the college students and school students, they should use this, and I am showing the interface of this MS mathematics. So, you can see this, if you see this screen left side, it is the options here. It is first option is calculus, statistics, trigonometry, linear algebra, standard calculations, and favorite buttons. These are the Microsoft Mathematics interface, and here two options, worksheet and then one is graphing. There are very nice graphing options, and all the graphings are there. In 2D we have Cartesian coordinate system as well as polar coordinate system. So, anything we can plot in this, and 3D we have spherical, cylindrical and Cartesian, all these options are there. So, there are many examples are given here, and I will be doing first a 2D Cartesian coordinate system, and this will be, suppose we can take, there are some examples also given at the bottom. So, examples of let us copy that example and paste here, and it is x minus 3 whole square by a square minus y minus 2 whole square by b square is equal to 1. Can anyone guess what will be the graph of this function? Can you see this graph? It is showing very yeah, most probably I also feel so. So, let us enter it, and this data is here, and then graph. It is not exactly a circle, something hyperbola, yes, it is hyperbola like that. So nicely, and there is option for animate, trace, so many good options are there. It gives the values like that, and many other options are there. You can change the a values, and you can get this different functions like that, and then we can give a simple equation x square, sorry, and then enter, and then graph. X plus x plus 4, no graph, and you can check this with if you want to solve this, let us see whether what is the problem. Then there is a y is it recalled is equal to y. Oh, okay, it is y. Let me put it, let us see. Not valid bracket, it has taken at its own, no? I have not put bracket. It is taking at its own. Now it has come, some mistake was there. So, it has to be done like that. So, this is Cartesian plot, and if I want to solve it, how we can solve it? So, there is option for home and this equation solver. So, in equation solver, if you put this equation also, so this is the equation solution of this equation, and it can plot like that. There are also options for plotting, and so many things are there. So, you can go on exploring, and then there are provision for solving equation system of 2 equation, system of 3 equations. So, all linear equation problems you can solve here, these options are there. So, then there are equation solver, then triangle solvers, there are good triangle solvers. You can give the parameters and you can see the possible triangles, and if there is something not possible, that also it will generate like that. So, this is a very good tool for and what is the calculus? Calculus, if you have worksheet and go to calculus dy dx. So, dy dx, now if you put it x square, enter. So, it is output is 2x. Can you see this? Output is 2x. So, you can go on practicing like that. D square x is equal to now again x square. Let us see what happens. D square x square by x square is equal to 2. Okay. And then if you want to integrate x square again, so x cube plus c, like that, anything you can. And if you want to integrate from 0 to 5, definite integration, then x cube dx is equal to 156. So, you will get readily that. You can do summation, limit also you can do. X square is equal to 0, then 1 by x. So, indeterminate means 1 by x when x tends to 0. Okay, I have not explained that what is limit, is not it? Any idea about what is limit? So, now you see this tool is there, it is tool is there to calculate. So, you can all the limit problems in given in this book, no, you just go on trying 2 minutes, 1 minute it takes for taking. But what does this limit mean? That is important now. Earlier our focus used to be how to calculate it, but now laptop is calculating for me. Now, I see the result is output is indeterminate. So, what is that indeterminate? Why it is not? Let us take another case. Limit x is equal to 2 and then 3x. So, when x 3x minus 2, when we tend x towards 2, limit to x limit to 2, then the limit value is 4. Now, take your mic. What is limit? Why we require limit? Can you tell something why we require limit? Yes.
By finding the limit, we can get the idea in the graph sense.
What idea?
In that particular function, at that point, what happens in that graph as x tends approaches.
Why we approach? You are right. When we approach, then we get a value. Why we approach?
Not clear idea about that.
Limit is giving a sense that if we are heading towards the given point from right or left, what change would it make in the fx value?
Okay, it is okay, but why we tend to that point? Why we approach?
Like for a case which we declared that the limit is indeterminable. So
no, suppose it is determinable. Then
Function is defined at that point.
आपको कुछ आइडिया है?
For differentiation purposes.
But why we include another thing, limit? Differentiation we have seen that dy dx we can calculate it.
So that we can see that the function is continuous or not.
So why we require limit? Function is continuous, okay, whether it is continuous, how limit helps us? And where the limit appeared, how it started?
maybe to get a knowledge about the trend.
Yes, to some extent you are right, but exact problem is, I think, is something.
Like if we are studying, there's a chance that we'll get good marks.
That is a primary thing.
Yeah, so limit study means get good marks.
But Newton was not required to get good marks. He was already graduated. So why he was searching for limit? Now you let us come back to that earlier problem what we were discussing. We want that dy dx or slope of a point this was the thing. Okay. Now what was, now you think we don't know calculus. Newton has not born, Leibniz was not there, so we don't have calculus books. But I want a tangent line here. So how we can get that tangent line here? isn't it? So, what I will do, I will try to put a line like that. Okay. Now, problem is that that problem also solved with y is equal to mx plus c. I told you that any line requires these parameters to plot. So, m and c, otherwise you cannot plot that line. So, what is that line? We have only one point, nothing else. We know x and y, but x and y is not sufficient to plot a line. I am giving this example, but it can be a point, means two elements of x1, y1, x2, y2 something. So, we require to know all these parameters to plot that point. So, how we can get? We do not have m, we do not have c. So, I cannot plot this line. So, another fact we can say, from this line we can draw millions of lines, any line at this point with x and y. Suppose x is equal to 2 and y is equal to 2, x is equal to 1. Suppose we have these values. So, from these values, suppose it is 1 and 2, x is equal to 1 and y is equal to 2. From this point we can draw millions of lines based on m and c. We can go on changing m and c and there will be a line, but we are interested only particular this line, tangent line, which touches is one point, and that was the problem. How we will get that? This red line, we are interested in that particular line, how to get that. So, what this we used to do in our daily life, we used to take a close point and we used to draw this line. Physically we can do that also, we need not go to laptop or computer book, we can do that physically. If we are we used to do that, even I think 2300 400 years ago also people used to do that, but Newton has made it formalized, formal rule he has imposed on that. Earlier we are managing, we are taking close points and drawing, and we are managing our work, but Newton give a shape on those thoughts. So, what he has done? He also, suppose this is 1 and 2, this is our point. So, he took another point, as Mandar told us. So, common sense we do that, it is not that. So, any other point I have taken, this is suppose 1 and our curve some values are there. So, it is 2.2 something, 1.1 and 2.2, some values arbitrarily I have taken. So, these two, when we get 2 points, then we can draw this line, or from these 2 points we can calculate m is equal to y1 y2 minus y1 by x2 minus x1, like that we can use any formula and we can calculate c and we can plot this line. So, this thing. Now, Newton also did that, but now he was telling closely associate a point. So, very closely he took a point. Now, what is the definition of this close? For me, close is means this much distance, for you close can be this much distance, for you this much distance. So, this for me close is this. So, my line will be like that. For another person this close is this. So, his line will be that, but are those lines are tangent? No. So, we have a definition for closeness. So, what is the closeness? That is the limit. Limit is defined that it will be close point, and if this point tends to this, means I want to make it very close to this, but I do not want that it should be at this point, means it should be 1.001, 1.0001, but it should never be 1, is not it. So, that is why I try to close very close. So, limit is the means rate of means defined as closeness, how close. It should be so close, it will be very near to it, but at the same time it should not be the same point. If it is same point, then y2 x2 minus x1 will become 0, is not it. So, 0 is undefined, it will become undefined, but until it is very difference, little difference is there, and I had a animation for that also in Excel I have done. So, that is why it is we require limit. Okay. So, from that we got the solution, but now problem come, suppose my curve is like that. Now, I have taken 1.1 and corresponding values whatever may be 1.9. Now, this point is here, but this point is in curve, it is not in curve. So, this is not a tangent line here, because there is no curve at all. So, here we required, if it is also closing, no, it is I have taken in a very close interval 1 and 1.1. So, for mathematically it is okay, but actually this point is does not exist here, calculation we will get, but it is not there. So, what we require, it should be continuity, continuous means it should continuous in this way. So, we require that continuity. So, it is limit only will not help, is it should be a continuous function. And for continuity, why we used first I told some points in so, here we can see this what happened, it is not this is I am not showing, actually it is yes. Now, Now, you see this number system, and then when we started calculus, these are the confusing points. Now, we know that why we require limit, what was the problem, we cannot plot a tangent line from a single point. So, we have to take a close point, from that we require this limit. So, up to this, if you see this number system, set, relation, function, continuity and limit. Why we require limit, we know something. Then we are taken it should be continuous also, it should be continuous. So, why why this calculus start with number system? Now, this is the another question. So, we should talk about something in number system, how it is related to calculus. So, number system, how it starts, which is the first number system? डेसिमल बुढ़ा होने के बाद आता है. What is these numbers? How it looks? Okay. So, natural, because nothing is isolation. So, natural number system is this geometry is this. Okay. Then what comes? Whole numbers. 0, 1, 2, 3, 4, 5, 6, like that it goes. This is also. So, what is the next, what comes? In between something comes? Yes. Fractional numbers 0, 1, 2, and in that 1 by 2, 1 by 4, 3 by 4, like that, is not it? So, what is the difference between these two and this geometrically? Now, our number system was discrete, there was gap in between, no number in between, but now our number system becomes continuous. We have numbers in between two numbers. So, now our number system is not like discrete like that, now it has a continuous line. Then came integers. So, integers again these numbers, whole numbers, and with corresponding negative numbers minus 1, 0, 1, 2, 3, 4, like that it goes like that. But here also we have gaps in integer also. So, how we fill these integers then? No. Float, what is that float? You tell float, but as a layman, what is that float? Yes. Then which number came? And that is the importance actually. Number system is been taught from class 1 to 11, I told you. Yes. Rational numbers. We forget, but we should remember this sequence. Rational. So, in rational numbers when we add, then integers also becomes continuous line. And then we discover irrational. irrational, how you can define irrational?
पॉइंट के बाद एंड ही नहीं है.
हाँ ठीक है. और any other? These are the numbers which is a number, but it is not having place in number line. You cannot place a irrational number in these number lines, okay, but it is a number, you cannot ignore them. There are millions of numbers like that. So, with these irrational numbers, rational numbers, all these numbers are real numbers. Okay. So, real numbers is required because of this, because it is continuous. Any point you can plot in that, there is no discontinuity. So, we require a number system to learn. Then why we learn sets? All are related to calculus, but we study sets in isolation here separately. So, we never correlate why we study set. Any answer? Set first, do you have any? No, first you can you define the set? So, this sets is a well defined object, group of well defined objects. Well defined objects. Okay. So, why we A is equal to, we express like that 1, 3, 5, 7. So, this is the set of odd numbers, you can say, prime numbers also, it are all, I think all are prime. Yeah. 1 is not prime. So, these are the odd numbers. So, like that all these sets. Now, what is the relation between this and calculus? Why we require to learn sets? This question came anytime in your mind? Yes, sets are very important topic, is not it, in mathematics. But why it appears in, but they don't tell it is in part of calculus. They study in, they introduce it in. Okay. So, set is well defined collection of objects, and then why we require with that? Because we want to establish relation between two different sets, is not it? So, how we do that? Suppose you have B, another set. First two alphabets of English. Now, from this, what we can define, one term is there, another Cartesian, what is called Cartesian pair. Cartesian pairs means we take one from here, one from here, and we make a ordered elements and group them as a set. So, that set is R, suppose it is not R, suppose it is S. So, this is Cartesian pair is called A cross B, and we take this is a set again, this is another set, but this set is ordered pair of AB. Ordered pair means I take one, suppose this is AB. So, 1 A 3a, then 5a, then 7a, then 1b, 3b, then 5b, 7b. So, this is a set. Here all elements are ordered pairs, both are there. So, all these things. So, how many ordered pair or elements will be there in a Cartesian pair? This is 4 and 2, it is almost 8, 4 into 2, 8. But here we want to establish a relationship. So, all these ordered pair may not be related to each other. So, we do not it can form a pair, but this pair we are not interested if it is not related. So, we are interested in a related pair. So, though two related pairs, if we can find some elements which having relation, then we will form another set which is ordered pair, but having some relation. Means here A1 and A may not have any relation, 3 and A may not have any relation, but we are interested if to find out if these ordered pairs are in relation. So, this concept of relation starts here. Okay. Now, we can establish some relation from A to B ordered pair. Again some ordered pair there is a relation, but we are not interested in that. We interested particular relation where the terminology, domain, range and codomain comes. So, those relation we are interested. So, first was started with set, then we taken this ordered pair of the set, we created a ordered pair. From that we created a relationship, and then relationship, among the relationship, if all the elements of domain, means first element, suppose this is our domain, it should have corresponding elements here, it can have more also. So, if all this pair having a corresponding element here which is related, then we can say this is domain, this is range. And if this set having more than domain, means more than range, means many elements more than the ranges, then it is said codomain, and in those cases it is called this relation called function. So, very specifically three things comes, but what I feel, I also face problem, honestly I accept that. Now, I accept I do not know mathematics, because earlier I was shaky to tell it, yes, you know. So, everybody I will be caught that I am not that good in mathematics, but now I boldly tell I do not know many mathematics, and not knowing any mathematics is not a crime. Who tells openly that I do not know mathematics, they can learn better than who try to hide that they do not know mathematics. As such, I told you everybody knows mathematics, but when it this formalization many people do not know maybe, but when the situation comes, they establish this relationship, they take one from there, one from here, and they can make their any practical life. Many times we require this sort of thing. So, with this we have related function, continuity, limit and differentiability, or deliverability, wrong spelling, that is differentiability, it can be differentiable. So, these are the confusion we have, and after these thoughts, no, if you can go back and read again that class 11, 12 calculus book, and you can now beforehand you know that what this chapter do, then you can learn very better way. And at the way these books are written, it is very difficult to understand. After completing also, it appears that this is not complete. means suddenly it has stopped, because we do not know why we started that. So, but when you know that why I am starting that, then it will become very clear for you. So, with that I am going back to my this lecture on few function we will be creating. This is another point you always remember, any function this will represent a line. Now, we will be plotting this in Excel. Here can you yes, this is actually Matlab. I have used this in Matlab. I from the morning whatever I was talking about was a function of one variable. So, y was related to x, but many times we face a problem that y is depending on many variables. So, what to be done in that case? So, in many cases we cannot explain it geometrically, we cannot show it geometrically, but for the case of two variable functions. So, function of two variables, it is earlier it was a function of one variable, now it is function of two variable. So, z is equal to x square plus y square divided by 10. So, this z is dependent on x and y. So, how we can express this function, how it looks like. So, I have taken some these are the functions created in 3D printing. This is function of x square plus y square, we get this type of surface. Okay. This is surface we get, and all 3D printing use that. So, this is x square plus y square by x minus y. So, x minus y, so odd functions surface it creates, because x minus y. So, whenever y is 0, x and y is same, it happens in many points. So, it becomes x minus y is 0, division by 0 is anything infinite. So, this surface goes to infinity and then again come back from minus infinity, is go to plus infinity and it starts minus infinity. So, until unless I could plot this, I never realized that how the shape of this function will be. So, like that your book also this is another problem with NCERT books or any other books. They give the so complicated functions, no, apparently it is very difficult to learn the basics of these things. So, my opinion is that you give simpler problem to learn, and once they get means master on those basic things, then you give this formula like these complex formulas. Otherwise, we never can understand this what the shape, I cannot do anything, and this is true for all the differential equation problems. They have given so complicated differential equation problems in 12th class. It is very difficult. I tried to plot those things in Matlab, and Matlab also fails sometime to So, we should give some simple for equations, so that students learn the intricacies, and then when they master and when they require these difficult things, they will automatically learn. But putting these complex formulas, no, you are means many people are going away from the mathematics. So, that is another observation is that. So, like that this formula is there. So, here what is the thing earlier y is equal to x square. So, what we are doing, we have a domain like that x and we are plotting the y, and this used to be some graph like that. But now we have z is equal to x square plus y square. So, how we can plot that? So, this is the thing. Earlier x is all this x minus infinity to plus infinity and correspondingly y. So, what will happen with this? So, there in this case what we will do? So, this is our domain, and all these z values will be dependent on this x and y. Suppose this is 2 and this is 3. So, a point 2 and 3 is not it? No, 3 and 2, sorry, 3 and 2. So, what will happen, these 3 and 2 points actually corresponding z means 9 plus 4, 13 by 10. So, 1.3. So, that 1.3 values where will be? It will be excluded something like that, is not it? So, if you think it as a horizontal plane, then the surface z surface will be something floating like this. So, this actually I have shown this in this graph. You can see this graph. Okay. So, this is the function of what I have plotted here, 2 x square plus y square. So, here formula was not that one. Two x square plus y square. So, how we plot this? Plotting this is also not that difficult. I think Mandar knows it, how it will do. So, if I take this a grid like that, so all the x values in this line, this line, this line, this line will be same, is not it? And if I take y value, so this will make a grid like that, and then every grid having a z values. So, we calculate it, and in Excel it is very easy to do that. So, I am not going to demonstrate it now. So, this is the function of 2D, and again coming back to this graph. You see, this is 2 lines is showing in this surface. These lines are this x axis and y axis, and any tangent line with respect to x axis, that is partial differentiation what we do, that is called partial derivative. Partial derivative towards x, that means a line it is parallel to x axis. Similarly, partial derivative with respect to y means a line parallel to that y axis. And then directional derivative comes. Directional derivative, what will that? When I move here, then the derivative is partial derivative. When I move from here to here, it is called partial derivative with respect to y. But sometimes I move this direction. So, then it is directional derivative. So, this formula changes, and it is the as it is a surface, then its tangent a plane which depicts its slope is a tangent plane. It is a flat plane, tangent plane. So, we calculate that flat plane here. I have calculated that also. You see that a tangent plane, and all these things we can I am showing it in Excel Matlab, because Matlab graphs are very nice to see, and I have done it in Matlab, but I have all these files in Excel also. So, my request is that you start practicing, because you have seen that one formula, one worksheet I am doing. I am not doing for every function, I am doing some new calculation. I am doing one, and we are just changing that formula. This is vector, this is I have done in Excel. Excel also you can do all these calculations, but this Excel graph is not that much good, that is why I have putting, but thoughts and calculations are all same. My actual means innovation, you can say this converting. This is a cube, no? This cube I am doing this cube because this is 3D, but it is plotted in 2D. So, it is appearing as a cube, though it is in 2D. So, this depth perception, how we can give the depth perception, that is the technique, and all these things can be done in Excel, and you can see it from different perspective also. Like that you can go on changing this. It is same thing whatever we want. Suppose when we visualize some object. So, first I see from this angle, then we rotate it, and then we rotate it. So, same thing I am doing, and these tools are with me now. I was not knowing that it can be done like that. So, once I get these tools, then it is very easy to do. Now, I will be doing this graphs to one to graphs, because you know that when we do one graph, we can create lot of graphs. So, not open, create new. So, here few polar coordinates, yes, right side. So, how Lyman cones, how we can create that? The formula is R is equal to A plus B cos t, and R and rest I do not require. So, suppose I want to, and all these things if you do, then only you enjoy actual mathematics. Lyman cos, Lyman cons, Lyman cos. Okay. So, you have actually it is polar coordinate. So, you have t, then you have r, then you have x, and then you have y. So, if you plot this, then you get this all rows, petal, number of petals, and then what will happen, lemniscates, Archimedes spirals, how you can do, let us see. So, I start with 0, t is equal to 0 means angle is equal to 0, 0 is equal to this plus 0.1, and I take it up to okay, sorry. Is it okay? So, 6.28 or 6.3 I take. Okay. So, it is a complete circle I am taking angles, and then R is R, or you can say B. Here it called A and B, two parameters are there, A and B. So, A and B you can take any constant value is equal to 1, suppose we take 1, A is equal to 1 and B is equal to anything, you can take 0.7. So, our formula is given is equal to A plus B cos t, B is this into cos. So, we got R, and you see this R goes on changing because of this angle, different angle R is changing, and x is equal to R cos t is equal to this is R into cos, and in this process whatever you learn you need not remember anything, it automatically once you start practicing, no, R into sin t. So, if I plot insert, so you can see how nicely it has been plotted. Okay. Very simple, but in books same thing, it will take 3-4 pages, and you will ultimately you will not understand how where from this comes, but here everything is in your hand. So, like that if you copy it, move or copy. A is equal to B. So, and if you have to create that tangent, formula is same, everything. On all these things in analytical method, what will happen? You have to learn hundreds of formulas. Here you know that what is happening inside. So, that is the beauty of this, and once you understand this, then it will be for you to remember. You know that there is a pattern, and even though you forget in exam hall, you can create your own ideas, because you know the basics of things. And in competitive exams, actually I do research with IIT students. No, I try to. Is it okay? Hello. हेलो, ठीक है. Okay. Okay. So, should I show one tangent line how it works here? Because I want to avoid that, because it takes a lot of time to do that. If time permits, we will do later. Okay. So, here R again I copy this, move or copy and create a copy. So, this is another thing, what I should say, a square cos 2 t Leibniz-Gates. Okay. So, r square is equal to a square cos 2 t. So, there is no n. So, remove it. Now, 2 t is there, 2 we can do, r is equal to a square, a is 1 square into cos into 2 into t. Okay. Now, you can see. So, if it is having some problem, you can see the data, there is many places there is no data. So, that is being captured when you try to learn it modeling, but once you learn only formula, you will never learn. You can see the data is there is some num, that means it is not divisible by 0. So, now move or copy, here I am changing the, here n is equal to 4 and see the effect. So, you can go on playing like that, so many things are there. Then this book will become very handy and enjoyable. That time you are doing, you can see this how it is happening. Here we read it description, we never realize that it will change that, but when I changed from 2 to 4, I was knowing it will become a 4 petal. So, these things are there, and again let us see, somewhere it is written odd number and even number, what will happen there. So, here if we put 3, now it is 3 petals. So, like that you can put 3 petals, like anything you can do, and all these things you can think that the tangent line will go, it will come back again, it will go away, then come back, and all these things when we try to follow some cosmetic items, they are also follow some pattern like that. So, these are the ideas of when we calculate this. Oh, sorry. Can you see this data? When this x is there, all x's value from top to bottom is same, and y value is vertically x and 2, and then corresponding z value is x square plus y square. So, like that you can create any surface. So, this is again another series sequence, and this is the last thing. Okay. Now, coming back to integration, what is integration then? Okay. Integration, here we want that derivative at one point, that is differentiation. Integration is that we want that area below that function or curved line, whatever generate that we want to find the area below that. So, we are given the function like that, and we are asked to find the integral of that. Integral of that means we want to find y is equal to something like that, I think, is not it? Y is this and dx is this, y dx. Okay. So, how we can do that in Excel? X square. Okay. We want to calculate a 0, we have to do something next time so that this display becomes very large. Actually, this display is not that much good. Here dx I have taken as 0.1, is not it? This is y into this is dx. Integration is equal to so it appears 28.3. So, now we can check whether it is right or wrong. We have this what I should say Microsoft Mathematics, where is that? Yes. So, our formula was integration this one. Okay. So, x is equal to 0 to 3 and 3 into x square 27. Yeah. So, it is close to that. If you take this 0.01, you will get more accurate results or like that. So, this is actually integration, nothing rocket science or something different like that. What we earlier I used to mechanically learn all those things. I never realized that it is these things are there. So, now we can this is definite integration, and if you want that indefinite integration of this, definite integration of this, you can get it here again, this dx 3 x square, sorry. So, x cube by 3. So, up to 3 it is when it is 3, then it is 27, is not it. So, you can cross check again, you have tools to cross check. Many times I was doing solving this problem, but I have no option to cross check whether I am right or wrong. So, unless you start using these technologies, this is very difficult to understand these things. So, with this we will be breaking for some 15 minutes, 10 minutes, and then we will come back again with a new topic, and what will be the differential equation, and what is series, why we use series. These two we will discuss and we will finish then. Okay. So, break for 15 minutes. Welcome back. This is our final session or last session or fourth session of workshop on calculus in MS Excel, and morning to this time we have discussed about the differentiation and integration a little bit I have shown. But I want to highlight something about drawbacks of existing system of teaching calculus. What is that? Suppose we are given here one, you can see in the board that one problem, find the velocity of a falling body at a time t, and here we are given a displacement s is equal to half gt square formula, and we plot on that and we calculate the derivative of that thing, and matter ends there. But we, in doing so, this right hand curve what I am showing, in doing so what happens that we forget about what is happening with that object which is falling. We see here it is a graph, but we forget to see that actual behavior of the falling body. So, what is happens when it falls a object from the top, then it starts gaining momentum, and velocity goes on increasing, and that depicted in from the second first graph, I think that I have shown. So, if we cannot model it, we never realize that this speed velocity is increasing like that. We cannot see the velocity from the curve. We can intuitively think that yes, this slope is becoming steeper, so velocity is increasing. But actual model we forget to do that I have shown in left hand side, and we can animate it. You can see that initial the delta t will be same for the same interval of time, the velocity will go on increasing. So, whenever we learn, we should create the physical model also, my suggestion, so that you can correlate both. And similarly, when we talk about this limit, all these things, I think we can, I have shown this limit, how to calculate this limit at a point, 3 approaches from left to right. You can able to animate it. I have done animation, and if you want that animation, it will, this file will be available at our Google Classroom. I think I have shared Google Classroom. So, there I will be uploading this presentation also and Excel file also. In addition to that, if you feel that I require more clarification, you can write on that, and we have Telegram group. In that Telegram group also you can ask question, and this we will be in touch for next 1 year. So, it is not that after from going here you have to do all calculation and come back to me. It is not that. Whenever you do this calculation, and if you face any problem, you remember that there is a company who are there to address your point, and don't think that all this answer we will get in Google. Google is a generic definition, but understanding the mathematical and scientific concept, it is very difficult to understand many of the concept, even very small concept like what is determinant, what is, why we do that, many small things. It is very difficult to understand what is that, and for the same sake what is limit, again you go back and ask the limit. Now, you have an intuitive idea that we cannot draw a line from a single point. So, that requires some limit, means putting a very close point, and the closeness of this are the limit, the defined as limit. So, this type of explanation you will not get in many of the mathematical and scientific concept, and that is the problem I faced, because I was honestly trying to understand all these things. I left my job I had no exam pressure, even though I was facing problem to learn all those things. So, I understand that it is not that easy the way it is written there to understand. So, you are open to meet us anytime you. And these ideas, whatever ideas I have shown, this is extendable to vector calculus, it is extendable to the complex calculus, complex analysis. It is not limited to that. Thought is same. In real analysis, you get a physical meaning of that tangent line, but in other cases it is to some extent difficult to get. So, delta and eta, definition of limit, all these things are there. These are the things limit of two variables. So, this is equally applicable to complex analysis also, vector also. Application of derivative. So, these are the application. So, tangent, normal. So, when you get tangent, no, tangent is dy dx. So, you know that m1 into m2 is equal to minus 1. So, normal will be minus m2. So, 1 by minus 1 minus 1 by m1 will be your normal. So, like that you can easily correlate all these things. Maxima minima means where horizon the dy dx is horizontal. So, you that will either tell you that it is a minimum point or a maximum point. So, second derivative will give you whether it is minimum or maximum. So, these things. So, geometrically if you see that mean value theorem, this is very interesting theorem, a very easy thing, not that difficult. Once you plot it, at least one point where dy dx is equal to y 2 minus y 1 by x 2 minus x 1, this will happen, means actually what is this, a object, suppose a parallel object is there, means I should, you have a line like that and you have a function and you know that this function is touching here and here. So, definitely if it is goes like that, then it may not reach here, but if it is reaching here, then somewhere it has to bend, then only it can come here, otherwise it will go away. Where you see that Newton's canon, when it goes on, there is no problem, means it will go infinite distance, but if it is coming back, then mean value theorem applies. If it is coming back, somewhere it has to bend, and that bend here it is telling this slope of this point or dy dx at this point will be parallel to this point, this line. So, these points we know that x 1 y 1 and x 2 y 2. So, this is mean value theorem, nothing else. So, here slope is y 2 minus y 1, x 2 minus x 1. So, this you can calculate, it is there, but this point is difficult. So, there must be a point which is equal to this, and that line, this line will be difficult to this line. This is called for anything it is applicable, and this is called, but the way it is being written, no, it is very difficult to understand what it conveys. So, you when you try to do this is one time practice, actually it is not that huge time it consumes, it is not like that. If you start, you can finish it very short time of period, and once you do it, it will be a lifetime asset for you, that is for sure. Now, we live with some confusion, actually what is that thing, that confusion will not be there. So, these are the application and then integration and application. Integration, as I told, it can be many use, finding the area below the curve. So, now differential equation. So, this is another part of our this 4 part calculus. I told that there are 4 major divisions. One is the differential calculus or derivative, and one is integral or integration, or third is this differential equation. So, what is the differential equation and what is the difference between the integration? That if you understand, then everything will be easy. Here in differential equation, what is given? It is given a the tangent line, equation of that tangent line is given. You have to calculate the function whose tangent is it. So, geometrically all the activities related to differential equation, the differential equation related to some tangent line, this formula relate to some function which represented tangents at different points, and you are required to get that function. So, this is we can say like that. Here in differential calculus, this is given and you are required to calculate dy dx, is not it? What is dy dx? Now, in differential equation, you can say dy dx is given. You are required to find y. This is the thing, but again there is subtle difference, because integration also do that. So, sir, what is the difference between these? Integration, when this function is given, then we calculate directly this function, but when differential equation, it may contain that both the variables x, it can contain x, it can contain y, and it can contain dy dx, and you have to solve it, and once you solve it, then you will get the equation. And MOOPAD, Matlab, very easy, direct formulas are there. You can calculate those formulas and understand fast what is there. So, if I say that y is equal to sir, suppose you have given a differential equation of then what is the function? It is given. So, you are required to solve this. This is differential equation. You have to solve it. So, you will get another function, no? And what is that function? Y is equal to 2x plus c. So, dy dx is equal to x, dy dx is equal to 2. Okay. So, this is the thing, but actually here what happens is c, this you clear everybody. So, in this process what you are doing, suppose this calculation you get from technology. First, when you understand the concept, then by seeing you can write this. So, that is one thing. and what for it is required, what is the this function signifies. This function signifies a group of lines depending on the value of c. So, you can take a c is equal to 1, 2, 3, 4, 5, okay, c, and then you can take this y is equal to, you have to plot many of the similar lines, no. So, x is independent. So, you can take x is equal to 1, 2.1 to 5. This notation means that I want to take an interval 1 to 5 with an increment of 0.1, 0.1, 0.1. This is we use this in Matlab, and Excel also we do that. We calculate this. So, this is the interval, and we are required to plot this equation. So, this equation, when c is equal to 1, then you know that 2 is equal to x is equal to 2 is equal to slope. So, to some extent it will be like that. So, and at 2 it will be like that, 3 it will be like that, 4 it will be like that. So, these are the group of lines is the solution of this. So, here first thing is that you calculate different for different c, you calculate the lines. This is the major work for differential equation. It is not a very complex subject, but yes, the equation that will give, that they give here, that can be very complex, and many times it is difficult to solve manually. You have to take computer help. So, this is differential equation, and once you understand this concept, I think then you can solve anything, and you know that this equation I cannot solve myself, because you know whatever prior knowledge you have, you can take the help of technology. But other process, that plotting and taking c value, different c value, you can take and you can process it, and I have one presentation for that also. I will put it in Google Classroom, you can see this. So, this is the differential equation. There are so many methods are there, and I am not going all those things. dy dx is equal to y. So, it is all values. This I have shown some formula, dy dx is equal to x plus y. So, how this equation look like, that equation I have shown. All these equations are given in Matlab. Matlab you can directly put it. There is a package called Symbolic Math Tools, and I should not restrict the students of class 1, 2, 3, 4 also, they should start using. And now our I think there are many other So, this is one thing, and then this sequence and series, this is the last point of today's, and with that we will be closing. So, why we use the series and sequence in calculus? Jigal, kuch idea?
Sometimes we solve differential equation in power series, we get the solution.
Why? Why we go for that? This is one, anything?
Sir, this was answered, somewhere near around that transcendental equations are very difficult to analyze. So, And any system can easily analyze polynomials. So in order to convert those transcendental functions to polynomials, we need Taylor series and all those.
So, the thought is that, yes, you are right.
We
Thought is
want
that
to
any line, I told any function is a line. Similarly, any function, any line is a function, and any line can be expressed by a polynomial. Any line can be expressed as a polynomial. Polynomial is the explicit function, means it is y is equal to some values of x. It power may be 4, 5, 7, 8, 9, 100, that does not matter, but it is a function of x. So, any line can be expressed in that way, and so any function, if we can convert it into this polynomial function or explicit functions, then we can directly integrate or differentiate, because the integration of explicit function are very easy. So, those functions are difficult to find derivative and integration. We try to find this equivalent series which represent that function, and every series every function can be represented by some series, because it is a line and line can be seen, and there are many techniques for Taylor series, binomial series, Laplace series, transformation, Fourier series, all these are for this purpose. So, that is the purpose for study the series, but if you use the technology, it becomes very easy, because whatever we told, it is known to everybody, but it is to some extent vague, because we do not never get the reality behind these talks, how much valid it is, how much it can be reliable. So, once you start plotting this in Excel, plot one series, and then you change the formula, you can get all the series. So, you need not for every function you need not enter different create different series like that. Only one Excel worksheet you do, and then you go on changing the y series values, that is all. You can get all the series, and then you can plot it, you can see that whether it is converging or diverging. If it is diverging, it is of not that much use, but if it is converging, then it represent whenever a explicit function converges, it represents some line, or if it is a line, it is a function. So, indirectly these are related. Sometimes we face problem in, suppose we have something like that. So, how to find the area of this sort of thing, is not it? So, area of this sort of thing, but in integration we can do very easy, because these lines we can represent with some functions or some series or some many means we can do, and we can find the exact area of these things. Because mostly class 1 to 12 what we do, we try to find the area of this regular object. So, we do not face any problem, but when it gets distorted, then only our problem starts, and we have this calculus in our hand to solve all those things. And this is true for this finding, because if it is a line, we can easily find the slope of this, but if it is like that, then it is difficult to find the slope of this. So, these are the main things, if you keep in mind while you are doing this, then I think it will be very easy subject. So, with that any question? We have 3-4 minutes to have some question answer. Mandar, I expect something from you. कुछ तो डाउट बोलो. how these ideas what I have discussed in the morning is related to your satellite graphs. What graph you create in satellite?
Sir, depends. Lot of times we have attitude graphs.
Attitude graphs and
Basically, lot of other graphs we have, sir. Position, attitude, then data we are receiving, that we can graph, right, sir? Or amount of radiation, temperature, anything.
very good. So, how is there any relevancy with the things I talked from morning to now? Is it related somewhere?
Yes, sir. So lot of so obvious is in integration वगैरह when we are looking at the velocity graphs or something, position graphs of satellite. So to get a better idea of the motion of the satellite, we will use calculus only, sir. Area under curve and all those things, sir.
Yeah. So, now if you get any graph, you can put the tangent lines on that and you can see that how the changes happening. Suppose you have reached at altitude somewhere, and after that whenever your temperature is increasing or rising, it is showing a uniformity, or it is showing a function like that which is equivalent to e to the power x, whether it is equivalent to log x or whatever may be, means the rate of change of that curves you can calculate, and from that you can infer that how the that parameter is behaving at that altitude.
Yeah, sir.
So, now you see and get satisfaction, okay, this is happening, these changes, but the characteristics of changes can be defined by this, and you can plot the function also, and that will indicate where it is the steeply rising or it is slope is not that
Yes.
steep, all these things you can. So, everywhere you can find these uses of this in future.
Yes, sir. So like almost any value that we can graph the uses.
Yes, you can characterize it, its steepness or how it is changing the values.
Yes, sir.
So, any other question you? Ishan? Okay. So, with that we can break now, and can if you have anything, any suggestion, doubt, anything, you can share with me in Google Classroom, and at the same time you can share it with what I should say Telegram, WhatsApp, Telegram group. So, both our options are there, and encourage the students, many students, you come these courses because you have something in your back, base is to some extent okay. So, you are coming to these workshops, but there are many students, they are weak in base, and that is why they do not come forward. So, you encourage them also, it is.
All these concepts remain the same if this linear scale is converted to some other scale like logarithmic scale or
Everything same. It is line, no, I don't see, I am blind, I don't see any equation, I see the graph, I see this, it is a line. It is a line. It is a curved line or it is a straight line, but it is a line. Some curve having very nice characteristics, e to the exponential curve, e to the power x, it is what is the x value and y, what is the y value. So, dy dx is equal to the e to the power x, means y value and its derivative value are same. So, this is very unique curve in that way explanation. So, we will be closing our session now. Thank you for nice working here, and